The new problem, topological sort. What does the problem mean? If we have been given a graph where the edges are, it is a directed graph. Directed graph, we have to take care of that. If the u is directed towards v, so u must come before v in the ordering. This example can be explained because it will help us to understand. So if this is a graph, okay, like if we have a graph and this is a sorting, so for everything we have to see from 5 we go to 0, okay, 5 to 0, so 5 should come before 0, is that so? Yes. 5 to 2, 2 should come before 5 should come before 2, that is a scenario, yeah. And then we have 2 to 3, so 2 is coming before 3, yeah. 3 is coming, no, not required. 4 should come before 0, yeah, it's coming before 0. 4 should come before 1, yeah, it's happening. 3 should come before 1, it's happening. So what we'll do is very simple. Yeah, our time complexity will be also big O of vector plus edges, and express space will be of big O of v. Yeah. So how we are doing is very simple. We need three things to take care. One is DFS, one is a viz array where we'll check whether the element has been visited or not. The another one will be a stack. So our approach is very simple. What we'll do is that we'll create int with 0 an array, visited array, to mark whether the node has been visited or not. A stack will be created even on the same side. Stack is created. Now we'll iterate this part, this array, for int I is equal to 0, I greater than equal to v, I plus plus. If not visited, we'll call the DFS. And also we need an answer array or list, where not array, basically a list where we'll store the values. We need something, so we'll create a vector int answer. Now what we'll do, we'll pop if the element if this stack is empty, okay, if this stack is empty, you just push. If it is empty, you just return answer. If it is not so, if it is not empty, you do one simple thing, you will push back st.top in the answer and we return that answer. So what DFS, this is very basic DFS what we were doing. Like we'll create a node, we'll auto iterate adjacent list, if not visited will DFS. And one additional thing what we have added, after doing DFS, we'll add the node value inside the stack, okay. So what will happen, if we are here, we'll go here, we'll go here and add into the node, and we'll go here and add into the node. Similarly, we'll go ahead. What will happen, we'll get a stack, of 5 4 3 2 and 0, because this is not empty. Basically this, if we start, basically we always start with 0, so 0 started, nothing happened, we'll push it, okay. If I is equal to 0, nothing happened, we'll push it, st.top 0. After 0 we'll have 1, obviously 1 is going towards 3, we'll go to 3, we'll check if 3 is visited or not, if 3 can visit anywhere, no, this does not follow, we'll push it. Now after, then we'll add 2 and so on. That is the simple stuff what we'll do. Yeah, that's it. If we run, the stuff will work. Thank you for watching.